Now, some information about what VAC Toulouse is going to provide during an exercise of vortex over or not for a first familiarization with QVA. So first, the weather situation for that exercise, the situation at the time of the explosive eruption. So height flight level or lows located over northern Atlantic. A large eye extends from Caribbean to Madeira. This configuration favors fast west winds over Atlantic Ocean from Azores to northern and central Europe. Disturbances move via this rapid jet associated with clouds and precipitation from the ocean to northern and central Europe. On low flight level, southwest wind blows over your Azores. High pressure with moderate wind could spread ash clouds slowly in low flight level toward Iberian Peninsula. Only an intense eruption that lasts could provide ash cloud reaching Europe. The simulated eruption lasts 100 hours with a height plume up to 13,000 meters and provide 4 times more ash quantity as a regular eruption for such a volcano. Vortex derivative and provided data. So the exercise is scheduled in 2 steps. At the step number 1, the eruption is beginning. The ash cloud remove around Azora. And then for the second steps, the ash cloud reach Europe, Northern Africa, and Turkey. So Vacturus will provide current VAG, current ash concentration charts, some explanation pages of a QVA, extract from the flyer with an example of a Vacturus area, and provide some probabilistic data, so some QVA, charts and vertical cross-section video, some deterministic QVA, charts and vertical cross-section and videos, some polygon design on charts of ash concentration in entire atmosphere, some comparison, current data with future data, and also our website, VAC Toulouse, make data available. Here's some example. Example of VAG 2 days after the eruption. We can see that the cloud has reached Europe, Northern Africa, and will reach Turkey. And we can see 2 clouds, one other up other the other. We provide current and ash concentration charts from time 0 to time 80, and with the current result 0.2, 2, and 4 milligram per cubic meter. And then we provide QVA. So first some explanation about QVA. VAC Toulouse QVA ensemble sets consists of 100 forecast predictions plus the deterministic one. In addition to deterministic model run, the ensemble model runs are launched with the following source time parameters modified: ash ejection height, emission profile, that could be umbrella or uniform, quantity of ash particles, and also size of particles. Considering resolution, so height resolution, vertical resolution, and also the time increments of 3 hours, and the concentration threshold 0.2 2 milligram, 5 milligram, and 10 milligram per cubic meter will be the same as is mandatory. Here some example of deterministic QVA. Top on the left, you can see a shot of entire atmosphere, so the cloud from the surface up to the top of the atmosphere, and a polygon design on it. And you can remark that in that case, the ash cloud extends from the surface to the flight level 600. If we have a look at some layers, layers of 50 flight level thickness, as is mandatory, one at the surface on the low level, one in the middle level, and one in the height level. And now a comparison current VAG and future polygon on QVA. On the left, what can we remark? Over Atlantic Ocean, west of Canary Islands, current VAG covers the area with distinct low concentration under 2 milligram per cubic meter in low layers and high concentration only above flight level 200. On the right, we can remark that VAG polygon is not sufficient to know which flight levels contains low or high ash concentration. If we do a vertical cross-section across the ash in inter-atmosphere, we can remark that in point 1, ash will be encountered only above flight level 300. Point 2, there is very high concentration, but only in low level between flight level 100 and 200. And point 3, there is no ash. Another example, near the volcano, we can see that the ash cloud with very high concentration is extended from the surface up to the top of the atmosphere above flight level 200 and above flight level 300. Sorry. If you have a look, number 2, there is a high to very high concentration ash around flight level 300, and in the middle of the cloud, number 3, there is no ash. If now we do a vertical cross-section in the probabilistic data, what we can remark is that there is a probability to encounter ash in the height level fly. When we have a look at the deterministic data, there is no ash at that level, but it's not because there is no ash forecast by the deterministic model that it's not possible to encounter ash at that level. If we have a look at the vertical cross-section in probabilistic data, number 1, there is a probability to encounter ash in upper atmosphere. And if we have a look at number 2, there is a high probability to encounter ash, but with a low risk in high concentration. We provide also videos. Here an example with deterministic data. We can see the video of the concentration ash cloud from the eruption up to 3 days after. And then we provide some deterministic QVA data, and we try to explain the limit of that deterministic data. Here an example. In that example, we can highlight that there is no ash at flight level 500. Ash cloud doesn't reach flight level 500. And in order to estimate the validity of this forecast and the risk of flying at that flight level 500, or also in low flight level or the flight level, probabilistic information can help. Here, the relative frequency of concentration exceeding 10 milligrams per cubic meter. The risk of meeting ash cloud exceeding 10 milligrams at flight level 500 over southwestern Europe and Algeria is very low, but not null. The reason some members of ensemble have ash at this level, but most don't, including the deterministic model one. Here the same explanation, but for another threshold, for the threshold of 5 milligrams per cubic meter. Here the same with threshold of and concentration of 2 milligrams per cubic meter, and for the threshold of 0 for 0.2 milligrams per cubic meter. And then we can do another analysis is to estimate the risk of flying in low layer. Here, for example, we have the percentage of members exceeding 0.2 milligrams per cubic meter on flight level 100, then flight level 200, and then flight level 250. And we can highlight that over Atlantic Ocean, west of Canary Islands, it is unlikely to encounter ash from mean sea level up to flight level 200, and it is likely above flight level 200. Here, same analysis. And then with the risk above flight level 400. Let's look at other charts. Which ash concentration above flight level 300? If we do a vertical cross-section, it's possible to check with charts of concentration ash on a flight level or from a vertical cross-section. And with the vertical cross-section, we can remark the probability of encounter ash cloud on flight level above flight level 300 that is not null, where the deterministic data show no ash. And then we explain how to access to QVA data on the VAC Toulouse website during the exercise vortex. For first familiarization, a selection of QVA charts will be available on website VAC Toulouse and the VA through buttons as in example below. And then a question to regulator. A European regulator allowed to fly according to current rules. Flight authorization are accorded to thresholds of 0 to 2 and 4 milligrams per cubic meter. If we have a look at a polygon as it will be provided with QVA, here an example. What will the regulator allow is such an example of Etna eruption with a polygon of ash concentration exceeding 4 milligrams from flight level 80 to flight level 390. According to vertical crossing section, 2 or 3 crowds could be designed on a VHG. So here the difference between a QVA polygon and polygon on VHG. And then some QVA using APA where they will be provided on Medgate. I'll let you read some slides. Thank you for your attention.